So let's take a look at cylindrical and spherical coordinates. So starting off with cylindrical coordinates, they are always going to be in the form r comma theta comma z. So if we were to describe, let's say, point P in the three-dimensional coordinate system with the cylindrical coordinates r comma theta comma z, r is going to be that radius of the base of the cylinder. Or in other words, since the base of the cylinder is a circle, basically we're talking about the radius of a circle. So that will be the radius, or the r. Now theta is going to be the angle from the positive x-axis to the radius r, and then z is obviously just that z coordinate, or the z value. So that will describe point P. And so when we convert from cylindrical to rectangular coordinates, we will use three different formulas. The first one is x equals r cosine theta, y equals r sine of theta, and then z just equals z. So technically two formulas. The z value just stays the same, and then notice that these are similar to polar coordinates as well, when converting from polar to rectangular. So for number one, let's go ahead and plot the point 2 pi over 4, 1. So in cylindrical coordinates, remember, the 2 is going to be the r, or the radius value, pi over 4 is the theta, and 1 is going to be that z value. So let's go ahead and plot this. So the radius is 2, so let's go ahead and graph 2 on the x coordinate, or the x-axis. Then the theta is going to be pi over 4. So the distance, or the angle, from the positive x-axis, we're going to go 45 degrees outward. So 45 degrees, just go ahead and call that 45 degrees. Or in other words, pi over 4 radians. It's going to be something like this. And then the z value is 1. So that's like z value 1 is up here. Then the point is going to be somewhere around here. So that will be the point 2 pi over 4, 1. So now let's go ahead and convert these cylindrical coordinates into rectangular coordinates. So once again, x is going to equal r cosine theta, y is going to equal r sine of theta, and then z will just equals still the same, it will still be z. So x is going to be r, which is 2, times cosine of the theta value. Now theta value is pi over 4. Cosine of pi over 4 is square root of 2 over 2. So we get 2 times the square root of 2 over 2. The 2's will cancel, and so we'll get the square root of 2. Now y is going to equal r, which is still 2. Now this time sine of pi over 4. Sine of pi over 4 is also square root of 2 over 2. So we get 2 times the square root of 2 over 2. 2's will cancel, and we're still left with the square root of 2. And then z is equal to z. So our z value will still be 1. So the rectangular coordinates are going to be x, which is square root of 2, comma y, also square root of 2, comma our z value 1. So square root of 2, square root of 2, 1. Now for number 2, let's go ahead and plot 3, 0, negative 6. So 3 will be our radius, or the r value, 0 is going to be the angle in theta, and then negative 6 will be the z value. So we're going to go 3 units on the positive x-axis for our radius, and then the theta value is 0, so we're still going to stay right there. And then negative 6 will be our z value. So in this case, it's not on the positive z-axis, it's on the negative z-axis. So, and then we're going to go down 6. 3, 4, 5, 6. So the point will be somewhere around here. So now let's convert this to rectangular coordinates. So once again, x will equal r, so which is 3, times cosine of theta. Now theta is 0. Y is going to equal r times sine of theta. Sine of theta, so that's sine of 0. So cosine of 0 is 1, so we get 3 times 1, which is 3. Sine of 0 is 0, so that will be 0. Now for our z coordinate, it's still going to remain as negative 6. So our coordinates here, our rectangular coordinates, are going to be 3, comma 0, comma negative 6. So now for number 3, let's go ahead and plot 4, negative pi over 3, 5. So 4 will be our r value. So we're going to go 4 units on the positive x-axis. Now, notice the angle is negative pi over 3. So we're going to go from the positive axis, but this time go clockwise pi over 3 since it's a negative theta value. So we're going to go clockwise 60 degrees. It's around here. That will be our negative pi over 3 theta value. And then we're going to go ahead and go up z, or go up 5 on the z-axis, since our z value is 5. So the point will be somewhere around here. So now converting to rectangular coordinates, once again x is going to equal r, which is 4, times cosine of negative pi over 3. So negative pi over 3, or negative 60 degrees, in the unit circle, so we draw the unit circle, this is going to be negative 60 degrees, or negative pi over 3. That is the same thing as positive 11 pi over 3. So we're basically going to calculate cosine of 11 pi over 3. Now cosine of 11 pi over 3 is going to be 1/2, so we get 4 times 1/2, which gives us 2. Now y is going to equal r, which is 4, times sine of negative pi over 3. And sine of negative pi over 3 is going to be negative square root of 3 over 2. So we get 4 times negative square root of 3 over 2. And so that will give us negative 2 times the square root of 3. And z, our z value, or z coordinate, will still be 5. So in rectangular coordinates, it is going to be the x value, which is 2, comma the y value, negative 2 times the square root of 3, comma the z value, which remains 5. So now when we convert from rectangular back to cylindrical coordinates, we're going to use the formulas r squared equals x squared plus y squared, tangent of theta equals y over x, and z equals z. So once again, this is very similar to converting polar coordinates back to rectangular coordinates, and rectangular back to polar. So for number 1, let's change the rectangular coordinates 1, negative 1, 4 to cylindrical coordinates. So obviously 1 is our x value, negative 1 is our y, and 4 is our z. So the very first equation I would start off with is r squared, or the radius squared, is going to equal x squared plus y squared. So in this case, r squared will equal 1 squared, which is 1, and then plus negative 1 squared, also 1. So r will be the square root of 2. Now tangent of theta is going to be equal to y over x, so negative 1 over 1. And so theta will equal the inverse tangent, or arctangent, of negative 1. So what value did we take the tangent of to get negative 1? Well, be careful over here, because there are actually two values. Theta can either equal 3 pi over 4 or 7 pi over 4 as well. So we have to go ahead and graph these rectangular coordinates to see what theta value works. So if we go ahead and graph 1, negative 1, 4, so we'll go 1 on the x, negative 1 on the y, and then 4 on the z axis. So it'll be somewhere around here. So remember that theta is going to be the angle from the positive x-axis going counterclockwise, if the angle is positive. So 3 pi over 4 is a little bit less than pi, or a little bit less than 180 degrees. So 180 degrees would be around here. Well, that's not where we want to be at. We want to be at 7 pi over 4, which is a little bit further. And so that will give us that point. So in this case, our theta value is going to be 7 pi over 4. And remember, our z value remains the same, so our z value is still going to be equal to 4. And so the cylindrical coordinates of this specific point here is going to be r, which is the square root of 2, comma theta, 7 pi over 4, and then comma our z value, which is 4. So for number 2, let's convert negative 1, negative square root of 3, and 2 to cylindrical coordinates. So negative 1's our x, negative square root of 3 is our y, and 2 will be our z value. So r squared is going to equal x squared plus y squared. So x is negative 1, so negative 1 squared is 1. And then y squared will give us 3. So r is going to be equal to the square root of 4, which is 2. So that will be our r value. Now z is still going to equal z, so our z value will still be 2. And then tangent of theta will be equal to y over x. So in other words, negative square root of 3 over negative 1, or square root of 3. So in order to find theta, we must inverse tangent. So theta is going to be the inverse tangent, or arctangent, of the square root of 3. So arctangent of square root of 3 can either be pi over 3 or 4 pi over 3. Let's go ahead and graph these rectangular coordinates to see which one it is. So if we graph out here, So -1 on the x-axis, and then negative square root of 3 on the y-axis. Square root of 3 is a little bit bigger than 1, so it's going to be somewhere around here. And then we're going to go up 2 on the z-axis. So the point is going to be somewhere around here. Now pi over 3 is going to be 60 degrees, so that's definitely not it. We're not just going 60 degrees, we have to go 4 pi over 3 radians all the way over there. So that will be our theta value. And then our z value is obviously just 2, so the coordinates, the cylindrical coordinates, are going to be r, which is 2, comma theta, 4 pi over 3, comma z, which is still 2. So now moving on to spherical coordinates, they're always going to be in the form rho, comma theta, comma phi. So let's say I'm trying to plot a point P, which is in spherical coordinates, rho, theta, and phi. So now rho is going to be the distance from the origin to the point P. Theta, now the good thing is in cylindrical and spherical, both of them, theta is going to have the same meaning. So theta is going to be the angle from the positive x-axis to r, the radius, like in cylindrical coordinates, and so r is going to be right below rho. So r and rho are going to be right above and below each other. This is going to be theta, that angle, and so we can go ahead and draw dotted lines here to represent that r is going to be in the xy plane, but it's going to be right below rho. And so phi this time, phi is going to be the angle from the positive z-axis to rho. So that will be phi. And so keep in mind that phi has to be less or between 0 and pi. So it cannot exceed pi, it cannot be less than 0. So it's going to be positive and be in between 0 and pi. And p always has to be greater than or equal to 0. And so when we convert from spherical to rectangular coordinates, we're going to use the formulas x equals rho sine phi cosine of theta, y is going to equal rho sine phi sine of theta, and then z is going to equal rho cosine of phi. And we can also use the equation rho squared equals x squared plus y squared plus z squared. So for number 1, let's go ahead and plot the spherical coordinates 1, 0, 0. So 1 is going to be the rho value. The first 0 in the middle is going to be theta, and the 0 on the right will be our phi. Now in this case, it is easier to start with the phi value. So the phi value is 0. So the angle from the z-axis is going to be 0 degrees, and the rho value is 1, meaning the distance from the origin to the point is 1. And now theta, the angle from the positive x-axis, is also 0, so we just remain right there. So this is going to be the point, 1, 0, 0. So now if we were to convert from spherical to rectangular, we're going to use the formulas once again. X equals rho sine phi cosine of theta. So in this case, rho is 1. So x is going to equal 1 times sine of phi. Now phi is going to be 0 times cosine of 0. Sine of 0 is already 0, so we can just make our x value 0, or the x coordinate. Now y is going to equal rho, which is 1, times sine of 0 times sine of theta. Now sine of theta is also 0, so that will still give us 0. Now z is going to equal rho cosine of phi. And so rho is still 1, so z equals 1 times cosine of phi. Since phi is 0, we get cosine of 0, which is 1. So in rectangular coordinates, this is going to be the point 0, 0, 1, which as shown here is also 0, 0, 1. So keep in mind that if you don't know that you graphed it correctly, you can always convert to rectangular and see and double check your work. So now for number 2, let's plot the point 2 pi over 3 pi over 4. So 2 will be the rho, pi over 3 is theta, and pi over 4 is phi. So let's go ahead and start with theta. So theta is going to be the angle from the positive x-axis counterclockwise. So in this case it's pi over 3 or 60 degrees. something like this. And that's going to meet up with the r value. Now for phi here, phi is going to be pi over 4, so the angle from the positive z-axis is pi over 4, or in other words 45 degrees. And so that angle is going to meet up with rho, which has the value of 2. So rho is going to be 2. So this is going to be the point, 2 pi over 3 pi over 4. Now let's go ahead and convert these spherical coordinates into rectangular coordinates. So once again, x is going to equal rho sine phi cosine of theta. So in this case, x is going to equal rho, which is 2, sine of phi. Now phi is going to be pi over 4 times cosine of theta, which is pi over 3. Now that will lead us to 2 times sine of pi over 4, which is square root of 2 over 2, times cosine of pi over 3, which is 1/2. So the 2's will cancel, and so we're left with the square root of 2 over 2 as our x coordinate. Now y is going to equal rho sine phi sine of theta. So y will equal 2 times sine of pi over 4 times sine of pi over 3. So y will equal 2 times the square root of 2 over 2. The 2's will cancel, and then multiplied by sine of pi over 3, which is square root of 3 over 2. So we're going to end up getting the square root of 6 over 2 as our y coordinate. And now for z, z is going to equal rho cosine of phi. And so z will equal 2, which is rho, times cosine of phi, which is pi over 4. So cosine of pi over 4 is square root of 2 over 2. So we get 2 times the square root of 2 over 2. The 2's will cancel, and we're left with the square root of 2. So our final rectangular coordinate here is going to be the x coordinate, which is square root of 2 over 2, the y coordinate, square root of 6 over 2, and then the z coordinate, which is square root of 2. So now for number 3, let's say we're given a rectangular coordinate and we're trying to change it to spherical coordinates. So the first equation I would use is rho squared is going to equal x squared plus y squared plus z squared. So in this case, rho squared will equal x squared, which is 1, plus y squared, which is 3, plus z squared, which is 4 times 3, and that's 12. So rho squared will equal 4 plus 12, which is 16, so rho will be 4. Remember that rho always has to be greater than or equal to 0. So 4 is obviously greater than or equal to 0, so that will be our rho value. Now let's go ahead and find phi first. So remember that z is equal to rho cosine of phi. So what we can do to isolate phi is divide over the rho. So cosine of phi is going to equal z over rho. We know what z is, and we know what our z coordinate is, and we know what our rho value is. So we can go ahead and plug those into the equation. So cosine of cosine of phi is going to equal z, which is 2 times the square root of 3, over rho, which is 4. So in other words, phi is going to equal inverse cosine of square root of 3 over 2. So in this case, phi can either be pi over 6 or 11 pi over 6, but remember that phi has to be in between 0 and pi. So in this case, pi over 6 is the only option that we can choose for phi. So that will be our phi value. Now in order to find theta, remember that x is going to equal rho sine phi cosine of theta. So we go ahead and isolate cosine theta. So cosine of theta is going to equal x over rho sine phi. So cosine of theta is going to equal the x value, which is 1, or the x coordinate, over rho, which is 4, times sine of pi over 6, which is our phi value. Now sine of pi over 6 is going to be 1/2, and 1/2 times 4 is 2. So cosine of theta is going to equal 1/2, or 1 over 2. So then theta will be inverse cosine of 1/2. So in this case, theta can either be pi over 3 or 5 pi over 3. So what we have to do is go ahead and plot the rectangular coordinate points on a 3D coordinate plane and then see which angle it could be. So if we were to plot this on a 3D XYZ coordinate plane here, so we have X, Y, and Z. Now 1 is going to be the X value, square root of 3, which is a little bit greater than 1, is going to be the Y value. And then 2 times the square root of 3 will be the Z value, so somewhere around here. So the point will be around here. So notice our theta value, we only need to go 60 degrees counterclockwise, or pi over 3, to get under that point, which means our theta value is going to be pi over 3. So to write 1 square root of 3, comma 2 square root of 3 in spherical coordinates, we're going to write it as p, or rho, which is 4, comma theta, which is pi over 3, comma phi, which is pi over 6. And so that's the final answer.